Hi, my name is Charlize Chung, and today I will be presenting on how high-quality pollen diet leads to an increase in hypopharyngeal gland size in Apis mellifera. Alright, so the Apis mellifera is most commonly known as the honeybee and belongs to the genus Apis and the species Mellifera. They are a truly eusocial organism, which means they live in colonies, and they also have a caste system, which includes queens, nurses, workers, and drones, as they are separated into different jobs in order to operate as a superorganism. So why should we care about honeybees? Well, they pollinate many crops that are part of our food supply, especially fruits, nuts, vegetables. They are also essential to the necessary biodiversity that they bring to their ecosystem, and they also create products such as honey, royal jelly, beeswax, and more. Alright, so specifically the hypopharyngeal glands in honeybees. So the hypopharyngeal glands are part of their internal biology, and there are two paired structures located in front of the brain and between the eyes. Hypopharyngeal glands can also be measured by their overall size or their acini size, which is basically the smaller structures that make up hypopharyngeal glands. They play a critical role in nurse bees in order to produce royal jelly as well. So this is what makes these structures very important to the overall survival of a colony. So royal jelly is very important as it is used to feed larvae and also rear developing queens. So overall, it is necessary for honeybee diet and caste differentiation. And here's just a little figure of where the hypopharyngeal gland is located. Alright, and more specifically, how does pollen diet come into play with hypopharyngeal glands? So first off, pollen nutritional value and quality can be assessed by its crude protein levels or the composition of amino acids. So basically, whenever researchers talk about high quality pollen, they mean that it is high in protein and it has balanced amino acids. And of course, low quality pollen is the opposite of that. So pollen quality affects the longevity and performance of a honeybee colony. Alright, and poor quality pollen diet may lead to insufficient development of hypopharyngeal glands in honeybees. Alright, so on to our research question. How does a high-quality pollen diet affect the size of hypopharyngeal glands in honeybees? So our first figure comes from an article that was on the pollen diet quality on hypopharyngeal gland development. So in this study, they compared the effects of 7 different protein diets on the development of hypopharyngeal and acid glands in caged honeybees. So as you can see, those 7 diets are on this figure, and it ranges from a no protein diet to a synthetic feed to different types of pollen and a pollen mix. So these bees were fed on their respective diet when aged 1 to 8 days old, and no matter what they were fed, their hypopharyngeal gland sizes peaked on day 5. So as you can see, the bees fed with castanea, asparagus, or mixed pollen had the largest hypopharyngeal gland sizes amongst all the test groups. And these 3 pollen diets actually have a very high protein content, which means they are high quality pollen diets. And also a fun little tidbit, in free-flying colonies, castanea and mixed pollen diets were also primarily consumed over the rest from their free will. Secondly, we have an article that goes into depth on the research that they did on pollen and protein diets and how they led to larger acini, as compared to the control group where they were fed only water and high fructose syrup. So as you can see in the figure, the dark bar symbolizes the pollen and the gray is a protein supplement diet. And in all trials, you can see that the bees fed pollen or protein supplement had similar or increased acini sizes. And thirdly, we have a study that actually examined the combined effects of pollen quality and thiamethoxam, which is a type of pesticide, on hypopharyngeal gland development and protein content. But for the purposes of our research question, I will only be looking at the effect of pollen quality on the acini size, and as you can see, the dark bar is the high quality pollen and the gray bar is the low quality pollen. And on the 8th day and 12th day, where they measured the sizes, you can see that the high quality pollen diet resulted in a larger acini, specifically 11.5% larger acini sizes in bees fed with high quality pollen. So in conclusion, in our first figure, we found that amongst various protein diets, bees who consumed high-quality pollen had the largest hypopharyngeal gland sizes. In our second figure, we found that bees fed pollen or a protein supplement had larger acini than those who received neither. And in our third figure, we found that bees fed high-quality pollen as opposed to low-quality pollen had larger acini. So who did these results impact? Well, specifically, they impact beekeepers and how they feed and manage honeybees. With this knowledge of what type of diet and quality of pollen yields higher results in hyperpharyngeal gland development size, beekeepers are now able to choose pollen diets for their bees wisely and in order to yield the best results for their colony. We also now have a better understanding of what type of diet is most suitable for hyperpharyngeal gland development, which is one of high protein content and balanced amino acids. We also know how important pollen quality is for hyperpharyngeal gland development just by comparing high quality pollen diets and low quality pollen diets and the sizes of acini and hypopharyngeal glands. We also now have a better understanding of what may play a role in royal jelly production, since this is the primary structure that impacts royal jelly production. And we also have a better understanding of why pollen quality affects hypopharyngeal gland sizes, as hypopharyngeal glands need high protein content in order to grow. And here are my references, and that is all I have for this presentation today, and thank you so much for your time.